Okay, so we're going to start talking about linear inequalities. This is, again, it's a refresher. This is nothing new. I taught you this before the break. So linear inequalities, solutions to linear inequalities. We're going to talk about solutions to linear inequalities. A linear inequality is like a linear blank, but it has a blank symbol instead of an equal sign. So you can use keynotes in here to fill in these two blanks. You can use a linear inequality, and you can use an equal sign to fill in these two blanks. So a linear inequality is like a linear what? It's like a linear equation. Linear equations have equal signs, okay? But linear inequalities has a what symbol? An inequality symbol. Okay, so a linear inequality is like a linear equation, but it has an inequality symbol instead of an equal sign. Blank to linear inequalities are any ordered pair that makes the inequality true. So if I have an ordered pair x and y, and it makes the inequality true, I get a true statement of that ordered pair, that means that it's a solution. So solutions to linear inequalities are ordered pairs that make the inequality true. Okay, so number one, tell whether each ordered pair is a solution if the linear inequality. So I'm going to do number one for you. So I'm given 3, 9. 3, 9 as an ordered pair. Remember, ordered pairs are x and y. So that means that x is 3 and y is 9. Okay, x is 3, y is 9. Of this inequality, is that a solution to this inequality? Well, I need to see if it'll give me a what statement? A true statement. I'm going to substitute in 3 for x, 9 for y into this inequality. So 9 for y is greater than equal to 5 times x, where x is 3, minus 6. 9 is greater than equal to 15 minus 6. 9 is greater than or equal to 9. Is that a true statement? I cannot simplify this any further, so I'm going to stop. 9 is greater than equal to 9. Yes, that is a true statement because 9 is equal to 9. So this is a solution. The answer to that question would be yes. That ordered pair is a solution because when I substitute in the ordered pair into the inequality, I get a true statement. So yes, that is a solution. So I want you to do number 2 on your own individually on your PDF. So now I'm going to go on to the next half of the paper, graphing linear inequalities. So that is telling whether an ordered pair provided is a solution algebraically. Now we're going to graph and determine if the ordered pair is a solution graphically. So when graphing a linear inequality on a coordinate plane, 2 variables means that we need 2 number lines, which is the x and the y axes. We will use the graph of the related equation as a boundary line and shade above or below the line, depending on your inequality symbol, to show all possible solutions of the variables. Okay, so steps to graph. Step number 1, you've got to convert the inequality to slope-intercept form. You should remember that slope-intercept form is y equals mx plus b, or in this case, we're going to have an inequality symbol instead of an equal sign. You've got to solve for y and then graph the line on the coordinate plane. Why do we want to change to slope-intercept form? Well, we want to change our inequality slope-intercept form because our slope and our y-intercept form are easily identifiable. So we have this example. Y is greater than 2x minus 4. 2 is your slope. Negative 4, you've got to include that operation sign. Negative 4 is your y-intercept. Okay, so m is 2, slope is 2, b is negative 4, y-intercept is negative 4. So I'm going to use those 2 numbers to graph my boundary line in addition to my inequality symbol. Okay, so I've got to graph negative 4 first. You've got to graph your y-intercept first. Y-intercept is negative 4. I'm going to plot a point where y is negative 4. On the y-axis, I'm going to plot a point at negative 4. My slope is positive 2. Written as a fraction, positive 2 is 2 over 1. That means up to right 1. Up to right 1. It can also mean negative 2 over negative 1, which is down 2, left 1. But from this point, I'm going to go up to right 1. Up to right 1. Up to right 1. Up to right 1. Okay? So I have my points from my slope-intercept and my slope and my y-intercept. Now I need to determine, is my boundary line solid or dotted? Because remember, in inequalities, you can have a solid boundary line or a dotted boundary line. So that's where I'm going to look at this. Y is greater than. Y is greater than means that I'm going to have a dotted boundary line. And if you look at the note over here, dotted line for greater than. So I'm going to dot and dash this line. So my boundary line is not a solid, it's a dotted. And the key note that I told y'all is that if you see a solid line underneath your inequality symbol, it's a solid boundary line. Okay, I don't have a solid line under here, so it is a dotted line. So now I have my boundary line. Now I need to determine, where do I shade? Where do I shade? Well, y is greater than. Y is greater than. Where on my coordinate plane are my y values greater than negative 4? Well, that's going up this direction, correct? All these y values are greater than. So I'm going to shade above. I'm going to shade above where my y values are greater. So I'm going to have a dotted boundary line, and I'm going to shade above. Okay, that is how you graph an inequality. Now, to determine if a point is a solution or not, solutions to inequalities fall on the solid line or in the shaded region. So solutions to this specific inequality is going to be only in the shaded region, any point over in the shaded region, because our boundary line is dotted. Remember, solutions do not lie on dotted lines, only on solid lines. Okay, so I'm going to follow those same steps by doing 3 and 4 for you, just as an extra example. So number 3, my slope is 3. Whoops. My slope is 3. I was about to write x. My slope is 3, which means 3 over 1. Up 3, right 1. Or down 3, left 1. Okay? And my y-intercept is negative 2. Make sure you include that operation sign, negative 2. So I'm going to go to negative 2 on my y-axis, plot a point to represent my y-intercept. From that point, I'm going to go up 3, right 1. Up 3, right 1. Up 3, right 1. Up 3, right 1. From that point, I can also go down 3, left 1. Down 3, left 1. Okay? Now I need to determine, is my boundary line dotted or solid? Y is greater than. Y is greater than means it's going to be dotted. And greater than means I'm going to shade above. Okay, so I'm going to have a dotted line. I have a dotted line. And I'm going to shade above, where y's are greater than this negative 2 point, which is up here. I'm going to shade the region that includes those values. And the question says, is 5, negative 2 a solution? Well, 5, negative 2, 1, 2, 3, 4, 5, negative 2 is over here. Does this point lie in the shaded region or on a solid line? No, it is not in the shaded region and it's not on the solid line, so it is not a solution. Okay? Number 4, my slope is negative 1/2, which means I can go down 1, right 2, or up 1, left 2. You can put that negative with the 1 as the numerator or with the 2 as the denominator. And then my y-intercept is positive 1. So I'm going to go at positive 1, plot a point. From that point, I can go down 1, right 2. 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 From that point, I can also go up 1, left 2. Up 1, left 2. Up 1, left 2, up 1, left 2, up 1, left 2. All right, so now I need to determine, is my line dotted dash and do I shade above or below? Y is less than or equal to. I have a solid line underneath there, so my boundary line is going to be solid. And then Y is less than, which means I'm going to shade below. So I'm going to have a solid line connecting all of my points here. And I'm going to shade below to represent all the Y values that are less than my Y-intercept at positive 1. Is the solution 2, 0, or is the ordered pair 2, 0 solution? The ordered pair 2, 0 is this point here. Does that point lie in the shaded region or on a solid line? Yes, it lies on the solid line at 2, 0, so it is a solution. It's on the solid line. Okay, so for your classwork / homework that's due by the end of class tomorrow, you're going to finish 5, 6, 7, 8, and then do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.